Good morning, students. Do you all hear me?
Yes, sir.
Great. So let's talk about union, intersection, and differences of sets today. If you have two sets, A and B, then their union is defined to be the set of the elements that are either in A or in B. So here this or means like an element. If an element is in the set A, then it is in union. Or if an element is an element of the set B, then it is an element of A union B. And the last case, if an element is in both A and in B, that is also in A union B. So we say this OR is like inclusive OR, an element in A or in B, and an element in A and in B. So this OR here is inclusive OR. There are exclusive OR too. And their intersection is the set of the common elements of set A and B. That means the elements that is present at the same time in the set A and in the set B. And difference of two sets is the set of the elements of A that are not in the set B. So to compute the difference, you exclude all those elements of A uh, that are elements of B. So let's do some simple example. So given your set A is the element of 5 letters, A, B, C, D, and E, and B is a set of elements D, E, F. So A union B I guess you all know this elementary operations, yet I'm going over them again. Do you think the element A will go in A union B?
Yes, sir.
Yes. See, A is an element of the set A, but it is not an element of the set B. So that's okay. We said like an element in A or an element in B. Similarly, B is an element of A, it is not an element of B, still goes in union. C is an element of A and it is not an element of B, still goes in A union B. But notice D is an element of both of this set. So D also goes in A union B. Similarly, E is an element of both these sets. It is also in A union B. F is an element of B, not an A. F is also in A union. So you can translate the definition in this way to like A union B is the set of the elements of all elements in the set A and all elements in the set. You just combine them simply. If there are any repetitions, you don't do the repetition, because in a set, if you write 2D, it will not make a different set. A repetition of the same element in a set doesn't count. So this is A union B. How about A intersection B? It is the set of all those elements that are common elements of A and B. So an element X, which is at the same time in A and in B. So what are the elements? So A is in A, it is not in B. So it is not a common element. So it doesn't go here. Similarly, B and C are elements of the set A only. They are not in the set B. So that doesn't, they don't go in A intersection. So D is one common element which is present in both these sets, and E is another element which is common, which is present in both these sets. So D and E is the elements of A intersection B. And F is in B, it is not in A, so it doesn't go there either. So this is A intersection B. How about A minus, or difference of A and B in this order? We said it is the set of the elements of A that are not in B. So it is the set of elements of A that are not in B. The same X which is in A is not in B. So do you think A goes in A minus B?
Sir, A, B, C will be there.
Right. A is an element of A, it is not an element of B. So A goes there. Similarly, B is an element of A and B is not an element of B. So B goes there. Similarly, C goes there. But D doesn't go there, because D is an element of A at the same time B is an element of B. So we exclude that common element. Similarly, E doesn't go there because E is an element of A at the same time it is an element of B. So we exclude all those elements from the set A. Those are, or that are elements of B at the same time. So this is A minus B. How about B minus A?
Sir, just F, because F is
Only F,
letter
yes.
that is not present.
In A, right. So if we say like in words, it is the set of elements of B that are not elements of A. So only element of B that is not an element of A is the element F. So notice from here, A minus B is not in general B minus A. Like real number arithmetic is not the same as and notice here by definition A union B is the same as B union A. And A intersection B is the same as B intersection. So we're trying to say like the composition union and intersection as a composition, they are commutative. But difference is not commutative. So they gave you like few more examples. Please study all of them. We would like to explain A union intersection difference in diagram. Do you all ever heard about the Van Weyler diagram?
Yes, sir.
Yes. So before going there, let's define the universal set. What is an universal set? Do you have any idea of universal set?
Yes, sir.
Please go ahead.
So I think a universal set would be a set that has all the elements possible.
All the elements possible under consideration. I just add 2 words with your definition. So for example, if we are considering the sets of letters, English alphabets, so universal set would be the collections of all English letters, right? From A up to Z. If we talk about the natural numbers, then our universal set is the aggregate of all natural numbers. If we talk about real numbers, then all real numbers together forms our universal set. So anyway, so this is simply the idea. So let's think we will represent the universal set in certain context with the area of a rectangle. So everything or every possible elements under consideration is within the area of this rectangle. Then any subset of this universal set will denote it by a circular region there. Let's say this is the set A. Let's take another set B. So then their union means the elements, all those elements within the common area and exclusive area. So this is your A union B. So we say this is the diagram for A. So what would be a good diagram for the to denote the intersection of two sets? Let's say this is your set A, this is your set B. By intersection, we mean the elements that are present in both these sets. So which area is common to both this circular region? Oops. So this area is common to excuse me. So this is our intersection. What do you think how we represent the difference of A and B? Let's say this is your A set, this is your B set. What is A minus B then? So by definition, it is the set of elements of A that is or that are not elements of B. So now tell me which elements of A are an elements of B? The elements in the common part, right?
Yes, sir.
So you exclude this common part. Let me erase this. I made a mistake. This is your A. This is your B. So the part of the set A that is not a part of set B is the A minus B. So this part of A is not a part of the set B. So this is my A minus B. Similarly, what would be my B minus B? Part of B that is not part of A. So we exclude this part again, leveling or shading out this part. So now how about let's define another operation. Complement of a set. Let's define it here. Complement of a set. Complement of a set. There are several different notation to denote that. For set A, some people would like to define it and denote it by A bar, or some other will prefer to write A complement. Maybe some other people will prefer to write a head. So we'll prefer this one, A complement. So A complement is the set of those elements X such that X is not an element of A. To be precise, so now the question is where this X coming from? Could somebody tell me from where this X will come from? We said A complement is the elements set of all those elements that
For
are
me,
not
I'm
in A.
not sure about this, but the universal set.
Yes, from the universal set. That's the correct answer. Yes. So you can write it like more precisely. X is an element of the universal set. We denoted it with a such that X is not in A.
Sir,
Mhm.
is my audio quality good? Because I'm using a different microphone, so
Yeah, I'm hearing you well. Yeah,
Sir, I have a question. I'm kind of
go ahead.
curious about it. What
Mhm.
is the cardinality of universal set?
Mhm. What is the cardinality of universal set?
What is the cardinality of the universal set? I mean,
Oh, it
I'm
could
kind
be
of,
finite or infinite. Yeah,
so it depends on the context.
exactly. Yes, it depends on
Okay,
the context.
okay, sir.
As we said, like in our example, our universal set comprises of all English letters, right? All letters in English alphabet. So certainly its cardinality is 26, right?
Yes, sir.
So if we think about like all Breck University students, and then we study different subclasses of that student body, then our universal set is the uh, collections of all students in Breck University, right? And,
Yes,
and that
sir.
is and that is certainly finite.
Yes,
I
sir.
don't know exactly how many of you are there, but it shouldn't be more than 15 or 20,000, right? So cardinality of universal set depends on the context. Again, if I say, what is the, if we talk about real numbers, then our universal set is the collection of every possible real numbers. So what is the cardinality of the real number set? It is certainly infinite, because doesn't matter however big a number you say, I can construct another real number which is not in your collection. So certainly cardinality of real numbers, um, set of real numbers is infinite. And let me take the opportunity to tell you, there is a letter written like a fancy N, not, uh, we call it Aleph not. Aleph
Sir,
not.
is it the Hebrew letter Aleph?
Yes, yes, you're
Okay,
right. Aleph not. So in mathematics, the cardinality doesn't matter however big it is. We have given a notation Aleph not for the cardinality of R. And then we have constructed um, a, an ascending order of uh, cardinality of some sets, especially from George Cantor. We'll talk about later on if they comes in context. So anyway, so now we know the complement. So what do you think? How can we represent the complement of a set in Van Violet diagram? So if this is your set A, then all region outside your circle is the complement, right? Because a complement is the set of all those elements that are not in A. So this is a complement. So if you have more than two sets with the same idea, you can represent them in a Van Violet diagram. For example, let me show you one diagram with three sets. Let's say you have three sets. call it set A. So set B. So set C. So you know A union B union C would be the region inside all three circles, right? Uh, what is A intersection B intersection C in this diagram? Isn't it this common part? This part is common of these three sets. So now how do you represent um, B intersection C in the same diagram? B intersection C is the common part of B and C, which is this part, right? So this is your, do you see this green?
Yes, sir.
Yes,
Okay,
sir.
so this is B intersection C. And now let me draw one part and tell me what would be that thing. Well, how would you represent this part?
Sir, A union B prime.
A union
Sir,
prime, okay.
is going to be the subtraction of C and A union B.
C and A union B. Yes.
Oh, sir, I
Yeah, yeah,
apologize. I did not notice
yeah.
the other union part over there. I thought you
Okay.
just wanted the lower part.
Yeah. Just slower part. Let me color this part in a different color. Yeah, this part, this brownie. Is this brown or something else? I don't know. I'm very good at color. Yeah, someone said it would be C minus.
A unit, sorry, sir, I forgot the name of that symbol that defines unity.
Union.
Union, yes, sir. A union B
A
is
union
going to be
B, right?
subtract. Yes, sir. It's going to be subtracted from C.
Okay, this is the whole C. If you subtract A union B has something more than some part of C which is being excluded here. So it's okay if you unite A and B and then subtract from C. So A union B will include this whole part of C. So if you exclude this part, you are left with this part. So this is okay. Can somebody tell me, is there any other way we can get this same thing? Like if I subtract C minus uh, A intersection B, sorry, A intersection C, A intersection C part is excluded, and at the same time, if we exclude B intersection C, we'll get the same thing again. Let's put an extra bracket here. Well, let me draw another picture. Mm-hmm. Let's call them A, B, C again. How can we represent this shaded, purple shaded region? Any suggestion from anyone?
So we are going to take the common part of A and C, and we
Right.
are going to subtract B from that.
Subtract. You can subtract B from that, right? So one way is it is in the common part of A and C. So A intersection C, and then subtract B from that. So if we subtract B from that, the common part of B and A intersection C will be subtracted and we'll be left with that region exactly. Okay. Is there any way else we can get the same region? So how about if I subtract A intersection BC and then subtract from it A intersection B intersection C? Does it work?
Yes, sir.
Right. So B intersection C, um, from B intersection C, if you subtract like common part of all three sets, then the common part is, let me shade it like in a different color. What would be that color? It's gonna be hard to like. This part, right? Uh, the picture has been shifted a little bit somewhere. Anyway, so from A intersection C is this common part, and A intersection B intersection C is a part of this common part too. Like if you subtract that part, we are left with this purple shaded region. So anyway, these are ideas of like representing sets in Venn diagram. How about in terms of graph of functions? What are the intersections and unions? Let's say you are considering this example is a nice one. This set. It is the graph of the function fx equals to x squared. Are you all like familiar with the concept of the graph of a function?
Yes, sir.
Yes, sir.
Okay. Okay. So let's say if you are given y equals to fx, that's x squared. Then if you plot it in the xy plane, that means if you plot the points xy in this plane for several x, you will get a shape like this. So in general, we say this picture is a graph of this function. In fact, it is not. The exact definition is the set of all ordered pairs that consist or define this function is the graph of this function. See, whenever you input some x here, that is squared, and that x square is the value of y. So you can think of this whole thing as a set of ordered pair. First element is the value of x, and second element is y, which is x squared. And x is all real number because all real number can be squared to produce another real number. In other words, this is the domain of your function. Well, if you plot all these points on the xy plane, then all these points will lie on a particular locus, which looks like this. That's what we call the graph, or stretching or sketching a graph in that xy plane. And similarly, if you are given another function y equals to x plus 2, so that means you are considering another graph or another set of all ordered pairs on the xy plane, where first and second element is related in this way. Second element, or y, is 2 more than the first element. Here again, x is the any real number, which is the domain of your function. So in other words, like you are more familiar with this sort of equation, it is an equation of a straight line, y equals to mx plus c, right? So if you take like 2 points on this line, as we know, it represents a straight line. So you can sketch the graph in the xy plane. So this is my y equals to x squared. And this is y equals to x plus 2. Now they are saying, what would be their union? What is A union B? If you are given these two sets, what is A union B? What do you think? What should be A union B? Anyone can help me? What do you think? What would be A union B? So the set A is the points on this locus, and say set B is the set of points or set of all ordered pairs in the xy plane. Those are on this straight line. I don't know. So what should be their union?
Sir, will it be their intersection points or the points that they cover together, the area under the intersection?
So just simply follow the definition of union. So uh, so we know. So what is our universal set in this context? Can somebody tell me? What is the nature of the elements of set A and B? They are simply set of ordered pairs. We said in this class last time, every ordered pair represents a point in the xy plane, right? So our universal set is, see, it is the first component is a real number, second component is again a real number. So our universal set in this particular context is R cross R. You all get that?
Yes, sir.
power Cartesian product of the set R with itself, which is said like R square. So my subsets are subsets or collections of ordered pairs in the xy plane or in R2. So if we unite them, we'll get set of ordered pairs such that in this case, second element is 2 more than the first element, or second element is the square of the first element. Y equals to x square, that means the second element is the square of the first element. In this case, it is the set of ordered pair where second element is 2 more than the first element. So that means if you think about pictorially or in sketches on the xy plane, this set is the set of all points or all ordered pairs that lies either on this straight line or on this parabola. That's what they showed by tracing these two things in bold. So this is the union. Means the points either on this line or on this parabola uh, is in the union B. Does it make sense?
Yes, sir.
Yes, sir.
How about the intersection of these two sets? Common points, right? Intersection means the common point. So if you look at the picture, the only points that lie on the parabola and on the straight lines are this point and this point. So the intersection consists of only these 2 points. But how do we recognize them algebraically? So A intersection B, let me write out A intersection B in a similar fashion. It is the set of all ordered pairs such that y equal x square instead of or it would be and. Y equals to x plus 2. So now if y is at the same time x square and x plus 2, then do you think it implies x square has to equal to what? Right? Simply substitute this x square in this equation in place of y. Then you get x square equals to x plus y. So that means x has to be a solution of this equation, quadratic equation. So how do we solve this x square minus x minus 2 equals 0 equation to find the values of x? You all know how to solve a quadratic equation, right? You can factor it as if x minus 2 and uh, x plus 1 equals to 0. I guess you all know like middle term factorization of a quadratic term, right? or quadratic polynomial?
Yes, sir.
Great. Let me know. I'm making sure you know all these things. Don't think like sir think us so I don't know, so illiterate in mathematics. No, I'm just making sure of it. So you get x equals to 2 and x equal minus 1. So if x is 2, what is y? Then y is 4. See, you get 4 from both this equation. If you substitute x equals to 2 here, you get 4. X equals to 2 here, you get the same 4. So that means 2 is related to 4 on both this graph. And similarly, if x is 1, your y is minus 1, your x is 1. X is minus 1, it returns to 1. X is minus 1, this returns to 1 too. So on intersection, you have only two ordered pairs. One is 2, 4. And the other is minus 1, 1. So this is your intersection. Pictorially, these are these two common points on the two graph. So these are the 2 points in the intersection.
Sir,
How about, go ahead.
I apologize. Sir, for graphs, we will always have to mention the sets in this coordinate way, that we have to add the coordinates in the set.
I mean, by graph, we mean that if you are given a relation between two variables, y equals to fx, the actual definition of graph of f it is the set of all ordered pairs x, fx, such that x is in the domain of that relation or function. It is the definition of a graph of a function. But sometimes you can represent this set of ordered pairs in the xy plane conveniently. Then we say it is the graph. By graph, our mental picture, we mean it is a picture. But in mathematics, graph is this set. Sometimes you may be able to represent them or sketch them conveniently in the xy plane. Sometimes you may not be able to sketch that easily, but still it is the graph of this function. If I can sketch it on the xy plane or if I can, doesn't matter. It is the graph of the function. Does it make sense?
Yes, sir.
Great. So how about the difference between these two sets? A minus B. See, you can say it easily. A is the set of all points on this parabola. So A minus B is the set. We exclude the elements of A that are in B. So what are the points on the parabola which are also a point on this straight line? These 2 points, right? So you simply exclude these 2 points from the parabola. So this is the parabola and they have excluded these 2 points simply by leaving a hole there. And you can work out algebraically. So did you all try all those exercise problems up to now? Like a section 1.1 and 1.2?
Sir, I have not yet, but I plan to very soon.
Please go through each and every exercises.
Yes, sir. And I will bring up any problems that I find.
Oh, sure. You all are encouraged to ask your question in this class. Make sure you understand every detail you are reading. Make sure that is the way of studying mathematics. Like you have to work out as many exercises as possible, and only solving or working out exercises you can learn mathematics properly. I guess we talked about complement. We are not talking about complement anymore, except few examples. Let's explain this example. Again, the set A is the graph of the relation or function y equals to x squared. And this graph, as I said, it is the set of ordered pairs such that in the ordered pairs, the second element is the square of the first element. And in this context, our universal set is the whole xy plane, which is the set of all ordered pairs, which is R2. So if we take the complement of A, we said complement of A is the elements that are not in A. So we exclude all elements of A from the universal set, we get the complement of A. So if x square ordered pairs on this parabola shaped locus, then our complement is the whole xy plane except the points on this parabola. So they deleted the parabola from the xy plane to denote the A complement. See, they preferred the notation A bar for complement. This is same as our A complement. Well, again, go through all this exercise 1.6 and let me know if you have faced any difficulty. So they are saying is case the set xy in R2 such that sum of the square of these two coordinate is between 1 and 4. So let's draw these things here. Do you all know the geometric representation of this equation? Or in other words, set of points in the xy plane such that x square plus y square equals to a square. Do you have any idea? If yes, fine. If not, I will tell you.
Sir, I used to know about it, but I kind of forgot.
So
Sir, can you repeat the question?
I said like what geometric object is represented by all these points?
A circle.
Going to be a circle.
A circle. Okay, let me tell you again. You know the formula between 2 points in the xy plane, right? If you are given like 2 points, let's say x1, y1 and x2, y2. Can we extend our class by 10 minutes today?
Yes, sir. I have a class at 9:30.
9:30. Then let's go up to 25, another 5 minutes.
Okay, sir.
Then
Sir, I had a question, but that's like outside today's topic.
it's okay, go ahead.
Sir, I was hoping, sir, in generally sets or groups, I think it's in groups. Every element has an order, right, sir?
In a group, if yes, every
But
element
why
has
do
an order.
elements have orders? Like, as far as I know, আপনি যদি real number element নেন, one টা একটাই থাকার কথা না?
Mm-hmm. Mm-hmm.
So one order to one হওয়ার কথা, but how can they have like different orders in multiple groups and others?
Okay. So the question is, the idea of order of an element of a group is completely different than the idea of the order of a set. Okay.
Okay.
In group theory, like let me tell you, let's say this is a group for an operation. Let me denote it multiplicative. Okay. Then a
Yes, sir.
certain element z multiplied with z itself by closure property of the group, it is another element of z. If you multiply it by another z, it is again an element of z. Multiply it by another z, it is again an element of z. That means I'm saying arbitrarily, if you multiply an element of z with itself n times, you denote it by z to the power n.
ও আচ্ছা, এর জন্য এগুলো এক একটা অর্ডার থাকে।
Right. For different z,
বুঝছি।
this product will turn into the multiplicative identity.
বুঝছি স্যার।
The
Thank you, sir.
smallest
Sir,
smallest
sir,
sus n is the order of the group element g. Okay. Well,
sir,
go
are
ahead.
we talking, sir, are we talking about the group of abstract algebra?
Exactly. Yes. Yes.
Sir, is that relevant to this course or something? I'm missing
Oh well,
something.
well, he was like a little bit confused about the order of some set and order of some element. So
Okay, sir.
I just wanted to explain, like, order idea is differently defined in different contexts. Well, particularly in this class, like, you can discuss anything, everything, because this class is all about like principles of mathematics. Anyway, but we will limit ourselves within the context of this book. Otherwise, we cannot study anything, everything in a 3-month semester. I mean, I don't know either anything, everything. I have very limited knowledge. So what is the distance formula? What is the distance from the point A to point B? You know, like, you take the difference of x's and square it, right?
Yes, sir.
Square plus y1 minus y2 and then you take the square root. This is the distance AB. So similarly, if you fix this point at the origin, that means if this point is your origin and this point is xy, then distance from the origin of a point xy so this is your origin. Then this distance, let's say this point is xy. Then what is A? A equals to x minus 0 square, that means x square, plus y minus the y coordinate of origin. Y coordinate of of origin is 0. So y minus 0 square, that means y square. So if you square both sides, you get x square plus y square. So think about, you are roaming around this origin, keeping at the same distance all the time. So you get this circle, right? The locus of a point which is equidistant from a certain point is called circle, right? So you are always maintaining the same distance a from the origin, and then you are moving. Then your locus is a circle. So this is an equation of a circle. Your distance from the origin is always constant a. So the xy's that uh, lie on your locus follows this distance formula. So this is the circle. So exactly on this circle, you get a square. Within this circle, what do you think? X square plus y square would be greater than a or less than a square. If the point is inside this circle, then x square plus y square would be what? Let's say this point has coordinate xy. On this circle, x square plus y square equal a square. Within this circle, x square plus y square would be greater or less of a square. Answer naturally. Or in other words, if x square plus y square root is a on the circle, what happened on inside the circle? Isn't this distance less than this distance a?
It is less than this.
Right. So if you square it on both sides, you get x square plus y square. Less than a. So how about if you take a point outside this circle? On this circle, x square plus, if the coordinate is same as xy, what would be x square plus y square relative to a square? X square plus y square would be greater than a square. So as I said, once you say x square plus y square is less than a, it is the set of all points xy within the circle x square plus y square equal a. As I said, xy says that x square plus y square is greater than a square. It is the region outside the circle. So now you can think of this one. It is the points, all points within the circle of radius 2, within and on, because they are using an equality here. And at the same time, these are the xy or set of ordered pairs or the points on and outside the circle of radius 1. So geometrically, if this is a 1 radius circle, then this is a 4 radius circle, then this set is the set of all points within 4 radius circle, outside 1 radius circle. So this is this region. Does it make sense?
Yes, sir.
Okay. If not, let me know. Next class we'll start from here. And I guess we talked about Van Euler diagram and everything. Wow, we have covered a lot today. Next time we'll start from 1.8 index set. And hey, ladies and gentlemen, please read up to this, up to here, everything, and let me know your discomfort. Okay. Thank you. Thank you very much.
We do
Good, sir. Have
attendance
a good
today.
day.
I have a question, sir.
Go
Sir,
ahead, go ahead, go ahead.
sir, we didn't find any box enrollment link of this course.
Oh, I have not created any.
Okay, sir.
Do you all have this book with you?
Yes, sir.
Okay, just read the book, and I'm sending you all my lectures, right?
Yes, sir.
Great, great.
Yes, sir, we're getting that, but I couldn't access lecture 2, sir.
What
Yes,
is
sir.
what is
Me
problem with
neither.
that?
Sir, you sent us a drive link, so I tried
Yeah.
accessing that with both my emails. It requested an access. You have to give me permission right now. So once you give me permission from your side, I can access that.
Okay, okay, okay. I will check your email and I will streamline all these things. Okay. Okay, make sure you are reading the book in every details. Yeah, that would be the key. Reading and trying to understand everything. And if you have difficulties, let's discuss everything on the floor in class.
Right.
Okay, let's see. Where is the attendance sheet? I don't know. Let's open the attendance sheet. Take the attendance. Is there any credit for attendance? I don't know.
Sir, it's up to you. আপনি যদি হচ্ছে
No, I don't.
মার্কস রাখতে চান তাহলে রাখবেন, না হলে রাখবেন না। It's up to you.
I don't like it. Like, I believe in you can study yourself. No, you don't have to come to my class to learn all these things. Yes, coming
Sir,
to
present.
the Mehjabin Pushpo.
Present,
You're
sir.
present. Thank you. Fatima Fiza.
Yes, sir.
Fahim Firdaus. Yeah, he's not here today. Saeed bin Miraz. Okay. Mahdiuddin Ahmed.
Yes, sir.
If I don't spell your name correctly, please let me know. Mohima Chaudhary.
Present, sir.
Tasfiya Tanjim Ahmed.
Present, sir.
It's a difficult name. Wasitaha.
Present, sir.
How do you pronounce your first name?
Masharat Wasitaha.
Masharat Wasitaha. Do you know the meaning of this word? I'm sure it is an Arabic word.
Yes,
Masharat.
it is an Arabic word. It the whole name means pure joy, actually.
Wow. Sumaya Fin Fatima.
Present, sir.
Ritik Rainath.
Present, sir.
Marjan Ghani.
হ্যাঁ স্যার, প্রেজেন্ট।
Ghani, in next class, you're going to tell us about your title. Is it a title, Ghani?
হ্যাঁ,
Okay. Okay. Next class, let us know what Ghani is.
জি স্যার।
Okay. Fardin Rahman.
Present, sir.
Jannatul Mawajoi. She's not here today. Sultanul Arifin.
Yes, sir.
Orkaroy is here.
Yes, sir.
Ghulam Musabbir. Joy. Ghulam Musabbir. Let's make it one. Okay, okay, boys. Thank you very much for attending my class.
Assalamu alaikum, sir.
Assalamu alaikum, sir. Have a
Walaikum assalam. Walaikum assalam.
Sir.
Walaikum assalam.